So where do we start?
Let's start with the most basic choice you make when moving to the cloud. How much control you're willing to give up.
The classic three service models. It's really a spectrum of management, isn't it?
It is. On one end, you have IA, infrastructure as a service.
Right. IaaS, this is where you have the most hands on the keyboard.
That's it. Azure gives you the virtual server, the networking, the storage, but the operating system, the patching, the applications.
All of that is on you. You're still managing a server. It's just not in your own closet anymore.
Exactly. Then you move down the spectrum to PAN-AVS, platform as a service.
And this is where things get a lot easier for developers.
A lot easier because now the cloud provider Azure manages the OS. They handle the patching. You just worry about your application and your data.
The speed you gain there is just incredible.
It's a game changer. And at the far end of the spectrum, you have SaaS, software as a service.
The lowest possible management. You're just a user. Think Microsoft 365.
You've got it. You don't manage anything. You just use the software.
But there's a new evolution here, isn't there? Serverless or function as a service.
Yes. And it takes the PAN-AS model and just cranks the efficiency dial all the way up. It's built on this amazing paper execution model.
So you're not paying for an idle server. You're literally paying only for the millisecond your code is actually running.
Down to the sub-second. It is the peak of operational efficiency.
That talk of efficiency and responsibility leads us right to security. The shared responsibility model.
Ah, yes. The line in the sand.
So where is it? What's on Azure and what's on, well, on you?
It's actually very clear. Azure is responsible for the security of the cloud, the physical infrastructure, the hosts, the network, the data center itself.
They secure the building.
But you are responsible for security in the cloud, your data, your endpoints, your user access. I mean, if you configure a storage account to be public to the world.
That's on you, not on Azure.
100%. The building is secure, but you still have to lock the door to your own office.
That's a perfect analogy. Okay, so let's talk about that physical building, Azure's global infrastructure, regions and availability zones.
Right. So a region is just a geographical area with a set of data centers. When you're choosing one, you're looking at three things: latency to your users, what services are available there, and, of course, the price.
And prices do vary by region, which is a key point.
They do. Now, within a region, you have availability zones, or AZs.
And these are the key to high availability.
They really are. Think of them as unique physical locations inside that region. Each one has its own independent power, cooling, and networking.
So if one AZ goes down because of, say, a power outage,
your services in the other zones are completely unaffected. This is how you protect against a whole data center failure. You just have to know if your service is zonal, meaning it's pinned to one zone, or zone redundant, where Azure handles replicating it across zones for you.
that brings us back to cost again. Pay-as-you-go is the default. But where are the real savings for an administrator?
The real win is commitment. If you know you're going to need a VM for 1 or even 3 years, you use a reserved instance.
And the savings are significant.
Up to 72%. That is a massive, predictable budget saving.
Okay, but then there's the high-risk, high-reward option. Spot VMs, discounts of up to 90% sound amazing. What's the catch?
The catch is eviction. Spot VMs are Azure's spare capacity. They sell it to you cheap. But if they need that capacity back for a regular pay-as-you-go customer,
They can just take it back.
with as little as 30 seconds notice. So you can only run workloads that can handle being interrupted. Think of batch processing, rendering, some testing.
But never, ever a production database.
Never. It's an administrative line you just don't cross.
Okay, that makes sense. So let's dive into that admin's dilemma. We have our VMs. How do we keep them running? Availability sets versus those availability zones we just mentioned.
This is a classic point of confusion, but it's simple when you frame it right. They protect against 2 totally different types of failure.
Okay, break it down.
Availability zones, like we said, protects you from an entire data center failure. You need to deploy your VMs across a minimum of 3 zones to get that protection. It's the broadest possible shield.
And if the failure is smaller, just a server rack fails inside one data center.
That's where availability sets come in. They protect you from hardware failures within a single data center.
How do they do that?
They use something called fault domains and update domains. Basically, it makes sure your VMs aren't all on the same physical server rack or sharing the same power source. So if one rack gets maintenance, your app stays online.
So zones for site failure, sets for hardware failure. Got it. Now what about scaling?
For horizontal scaling, adding more machines, you need VM scale sets. They let you automatically increase or decrease the number of VMs based on demand.
And there's a pro tip here for anyone using infrastructure as code, right?
A huge one. Inside your ARM template, you can use the custom script extension. This lets you automatically run a script after a new VM is deployed.
So you could install your web server or configure an application.
Automatically. On every single VM that gets scaled up, it's a massive time saver.
All right, let's shift gears to the modern admin's biggest question, containers. When can I get away with Azure Container Instances, ACI, and when do I absolutely need the full power of Kubernetes with AKS?
It all comes down to complexity. ACI is beautiful in its simplicity. It's serverless. You just give it a Docker container and it runs. No clusters to manage, nothing.
Perfect for what, a simple web app or a quick background job?
Exactly. Dev tests, task automation, simple APIs, it's instant on container goodness.
So what's the trigger point? When do you know that ACI just isn't enough?
The moment you need your containers to talk to each other in complex ways, when you need service discovery, automated scaling, and coordinated upgrades across many different services, that's when you need orchestration.
And orchestration means AKS, Azure Kubernetes Service.
It means AKS. You're managing clusters, pods, nodes. It's more complex, for sure, but it gives you total control over a sophisticated microservices application.
So let's frame this whole compute choice one last way. The old IS versus PayS debate. A standard virtual machine versus an Azure web app.
It's all about what you want to manage. A VM is IS. Full control. You can make it stateful. You can do anything you want.
But you have to set up your own scaling with scale sets, your own load balancing with an Azure load balancer.
Correct. The Azure web app, being TAS, flips that. It's designed to be stateless, and it gives you auto-scaling and load balancing built right in.
So you give up control of the OS.
But you gain enormous operational simplicity. Your job shifts from patching Windows to just managing your application code.
That's a perfect lead into our final section. Governance and networking.
Uh-huh.
The guardrails for everything we've just discussed, starting with the Azure Resource Manager, or ARM.
Right. ARM is the control plane for everything in Azure, and at its heart is the resource group.
A logical container for your resources.
Right.
But there's a critical administrative detail here.
Oh, the most important one. You can put resources from different regions into one resource group, but, and this is the big but, if you delete that resource group,
You delete everything inside it. Instantly. No undo button.
no undo. I have heard horror stories, people deleting a test RG and forgetting they had a production storage account in there. It's an atomic unit of destruction.
Treat it with respect. So how do we define what goes in there? ARM templates.
Your infrastructure as code. They're JSON files that declaratively define all your resources, your parameters, variables, the resources themselves.
Best practice before hitting deploy on a big template.
Always, always run the what-if operation. It's a preview. It shows you exactly what ARM is going to create, what it's going to change, and what it's going to delete. It has saved me more times than I can count.
Okay, let's talk security rules.
Yeah.
RBAC versus Azure policy. People mix these up all the time.
They do, but the distinction is clear. RDAC role-based access control is all about who. It's about authorization.
So can this user read a resource? Can this group contribute to it?
Exactly. You're defining permissible actions. But Azure policy is about what? It's about governance and compliance.
So policy would say something like, all resources must have a cost center tag.
Precisely. Or, you are not allowed to deploy resources outside of this specific region. Policy defines permissible configurations. And remember, a deny assignment in RBAC always wins. It overrides any other permission.
Great distinction. Let's finish with the plumbing. Core networking, starting with the VNet.
Your virtual network. It's your private, isolated space in Azure that you carve up into subnets.
And how do we securely connect that VNet to other Azure services like SQL or storage without going over the public internet?
You use service endpoints. They extend your VNet's private address space to the Azure services, so the traffic never leaves the Microsoft backbone network.
Now, controlling traffic inside the VNet, NSGs and ASGs.
Your Network Security Group, or NSG, is your firewall. It has rules that allow or deny traffic based on IP, port, and protocol.
And the ASG, the Application Security Group.
The ASG is a lifesaver. It's basically just a tag. Instead of managing hundreds of IP addresses in your NSG rules, you can just group your web server VMs into an ASG called web servers and write one rule that applies to the whole group.
It's an object reference that simplifies the NSG.
I like that.
What if we have multiple VNets that need to talk to each other?
That's VNet peering. It creates a low latency, high bandwidth private connection between them. You can even do global VNet pairing to connect VNets in different regions.
Fantastic. Last topic, load balancing. The basic Azure load balancer versus the much smarter application gateway.
It's all about what layer of the network they operate on. The Azure Load Balancer is layer 4. It understands TCP and UDP. It just distributes traffic based on IP and port. It doesn't know what's inside the packets.
It's a traffic cop, but a blind one.
A good way to put it, the application gateway is layer 7. It understands HTTP and HTTPS. Because of that, it can do smart things like URL-based routing.
So traffic for images goes to one set of servers and video goes to another.
You've got it. And most importantly, it can integrate a web application firewall, a WF, to protect you from common web attacks. That's a huge security benefit.
That layer 4 versus layer 7 distinction is everything for a web admin.
Absolutely critical.
Wow. That was a really powerful run-through of the core decisions an Azure admin makes every day.
We covered a lot of ground, from IS versus POS to availability sets versus zones.
And that critical difference between RBAC for who and policy for what.
Getting these distinctions right from the beginning is what makes a solution that's not just working, but is also secure, resilient, and, cost-effective.
It truly is.
Mm-hmm.
All right, as we wrap up, here's a final thought for you to take away from this deep dive.
Let's hear it.
We know that Azure charges for data that leaves its network egress, but not for data that comes in. We also know that pricing and even features can vary by region. So the question is, how deeply should you, as an administrator, factor in geographical knowledge and data residency laws right from day one, not just for compliance, but to truly master cost optimization?
That's a complex one. It's the difference between a deployment that just works and one that is genuinely brilliant from a business perspective.
Something to think about. Until the next deep dive.